Hello everyone, I am Sindhu studying in Sri Venkateshwara College of Engineering 7th Sem EC. Today I am going to discuss about a subject called Automotive Electronics and the subject code was 18 EC 742. The topic was about a CAN bus protocol and a local interconnection protocol and a MOST protocol. Now I am discussing about a CAN bus protocol. The CAN stands for a Control Area Network. It is a serial communication protocol designed for embedded systems. It is used in a variety of applications including automotive, industrial and medical devices. CAN protocol is a robust protocol that is immune to noise and interference. It is also relatively fast with a data rate up to a 1 Mbps. The CAN bus protocol is based on a master slave architecture. The master node is responsible for initiating communication and managing the bus. The slave nodes respond to a request from the master node. CAN bus messages are composed of header and a data section. The header contains the message identifier, which is used to prioritize the messages. The data section contains the actual data being transmitted. The CAN bus protocol uses a carrier sense multiple access with collision detection mechanism to control access to the bus. When a node wants to send a message, it first checks to see if the bus is ideal. If the bus is idle, the node can start transmitting. If the bus is not idle, the node must wait for a random amount of time before trying to transmit again. If two nodes try to transmit at the same time, a collision will occur. When a collision occurs, the nodes involving will back off and try to transmit again later. The node with the high priority message will eventually to able to transmit. The CAN bus protocol is a reliable and a efficient protocol that is well suited for variety of applications. It is easy to implement and use and it is supported by a wide range of hardware and software. Here we can see the CAN bus network using in a vehicle wiring. The CAN bus protocol can summarize it in a following manner. The physical layer used to differentiate transmission of twisted pair wire. A non-destructive bitwise arbitration is used to control access to the bus. The messages are small and are protected by a checksum. There is no explicit address in the messages. Instead, each message carrier are numerical values which controls its priority on the bus and may also serve as a identification of the contents of the message. CAN bus message frame. Message frames are labeled by an identifier assigned to one or more nodes on the network. All nodes receives the message and perform a filtering operation. That is, each node executes an acceptance test on identifier to determine if the message and thus its content is relevant to the particular node. Only the nodes for which the message is relevant will process it. All others ignores the message. Line bus protocol. It stands for a local interconnect network. Bus is a single wire serial network protocol that supports a communication up to 19.2 kbytes at a bus length of 40 meters. It is a low cost embedded serial network stands for connecting intelligent devices and is the most popular in automotive industries. The line protocol is a master slave type of communication where one master node can communicate up to 15 slave nodes. The line bus message frame is divided into major parts, namely, the message header is always transmitted only by master node and consists of a break and synchronization and identifier fields. The message response can be transmitted by both the master and slave nodes and consists of a data and checksum fields. The Line bit rates range from 1 to 20k bytes. Bit value on the bus are recessive and the smallest entity is 1 bit time. The line bus can be in a sleep or a active mode. All the nodes must be in a active mode when data is on the bus. The protocol is a byte oriented, which means the data is sent one byte at a time. One byte field contains a start bit, 8 data bits, and a stop bit. The data bits are sent LSB first. Data transmission can be divided into master task and a slave task. Here we can see the line bus in a vehicles, how it will operates through a line bus. Line bus message frame. The line bus is a pooled bus with a single master device and one or more slave devices. The master device contains both a master task and a slave task. Each slave device contains only a slave task. Communication over the line bus is controlled entirely by the master task in the master device. The basic unit of a transfer on the line bus is the frame, which is divided into a header and a response. Here we can see the message header and a message response. First, here a break and synchronize, after identifier and data, and it will check some in a line bus frame. Now, the most bus protocol. Most transfer a media oriented system protocol. It is a critical transport in automotive need not so much bandwidth can be accomplished by technologies like CAN, LIN, etc. But one requirement in the modern vehicle is informative system and surrounding view reverse camera systems. Such a system need lot of bandwidth and very less latency that can't be achieved with the conventional vehicle networks. This is called a specialized bus and one of the key protocol that has revolutionized the way vehicle exchange data in a media oriented system transport bus. To comprehend the working of the most bus, it is essential to undertake how it maps to the OSI layer. The OSI is a framework of implementing network protocol and consists of a 7 layers, each with its own distincts. Here we can see the 7 layers of OSI model and a most protocol specification. It consists of a blocks, functional block, network services, stream services, NIC, INIC, optical physics, and electrical physics. Most bus message format. The media oriented systems transport a bus usage a specific frame format for transmitting data and control signals between network nodes. The understanding this frame format is essential for analyzing and interpreting the data exchange in the bus. The frame format of MOS protocol consists of a 1 byte header and 4 bits used for a synchronization purpose. Here we can see the most bus message format. One data frame for MOS 25 or 64 bytes and synchronization channels and asynchronization channels. And here we have a boundary descriptors, control channel, frame control, parity bits and preamble. Hope you understand these buses, CAN bus, LIN bus and a most bus. Thank you.